Hello, everyone, and welcome to the webinar. We'll get started in about half a minute or so. As I can see, a bunch of people are still logging in and getting set up. Okay, Amadeus, I think we should get the ball rolling. Welcome everyone to the webinar today. We know you're very busy, and we really appreciate you taking the time out of your busy schedule to spend time with us. And we hope this webinar will be productive or will be a productive use of your time. We hope it's going to be informative and interesting. Our topic is supply chain and logistics management with graph databases and AI. I'm David Ronald, Director of Product Marketing at PartnerGraph, and I am joined by Amadeus Tunis, Vice President of Data and Analytics at Publicis Sapient. Amadeus is a seasoned professional with deep expertise in developing and scaling new initiatives, developing and executing strategies, as well as managing programs focusing on data, analytics and AI, digital products, and cross-platform solutions. Amadeus has over 15 years of combined experience in the tech, media, and consulting sectors, having acquired and delivered programs and products for global clients across a multitude of industries with a strong focus on automotive. He currently leads the Publicis Sapient data and analytics practice in the DACH region. Welcome, Amadeus.
Thank you. How are you?
Yeah. So before we get started, before I turn things over to Amadeus, I just wanted to run through some housekeeping issues. As we all know, phone lines are muted, but we do want to hear from you. So please make this as interactive as possible by submitting your questions through the Q&A button. Next, we are recording the webinar, and we will send out the recording and the slides and any other materials Amadeus wants to share with you very shortly after we finish. Typically, it takes 2 to 3 hours, if that, for my colleagues in marketing to send that email. So look for that to hit your inbox shortly. And last but not least, if you have any issues with chat, we shouldn't, obviously. But if you do, let us know. So if you have any problems with Zoom, let us know through the chat button, and we'll do our best to get those addressed in a timely manner. So with that, I'll pass things over to Amadeus.
Thank you very much, David. So today I would like to talk a bit about supply chain and logistics management, leveraging graph technologies in the GraphDB and AI. Now, looking back into the PartnerGraph channel, I've also looked at some of the former webinars, and one that I can really recommend is the one that was actually published last month, which is also about supply chain optimization. Whereas the interview and with the PartnerGraph partner Expero dives a little bit deeper on the technical side, today's talk will be a little bit more focused on the industry application and the business side. So I think in conjunction, both talks I think would really be well-rounded. If you've seen the last one, there might be some topics that repeat a little bit, but nevertheless, I feel like hopefully you'll gain a little bit of a deeper understanding, a broader understanding of the application from this talk as well. So let's get started. I'm actually just looking at the agenda real quickly. I'm going to do a quick intro where there are interesting applications of Graph and AI in this domain. Then look at some industry applications specifically, while also then taking a quick excursion into the data that might be something you're very familiar with or interested in that we typically come across to feed graphs in this domain. Then a few examples. I will be presenting just on a high level 3 graph examples today. These are just representative, not an actual data, but very close to what you could probably expect, and just kind of compressed so it fits on one page. Then also a 4-step approach, how you can get started, or how many companies tend to get started with the first project, MVP. And then a reference that where we at Publicis Sapient, being a consulting company, mainly also work on implementation, and we also build own solutions. So there's an interesting solution built on an enterprise knowledge graph, but not necessarily focusing for supply chain, but very useful for especially internal use and structuring unstructured data, or going searching unstructured data inside of a company. That would be it. And then I'm happy to answer questions at the end. So let's get started. So graphs add business value. If you didn't believe in that, you might not be joining this talk, but it is just something just to get us all kind of on the right level and just set up a North Star. So as you know, tons of unstructured data, something that grows exponentially, and more and more of the world's data, mostly being unstructured, gets generated in a shorter and shorter time frame in the past. So this is something that lots of companies struggle with, especially in domains of supply chain and logistics, where there's a high diversity and maturity of data. Then there, especially in complex systems or long process chains, there is lots of overarching questions that are not easily answered. Graph can supply a solution where you can really break it down, simplify it, make it more explainable, leveraging, GSQL for really questioning systems, and then also higher performance and broader data accessibility, while also, observing compliance. And then last but not least, querying, searching, asking questions of data through the graph structure. You can really accelerate queries, streamline processes, and thus enhance overall efficiency. So even very performant querying systems like Google BigQuery or something similar on the cloud, once you go past 20 joins, you start really seeing challenges to your performance. So when you have a different type of database that's not relational, this might really be something that can slice through that. So let's move on. Let's talk about a few applications in the sector, in the domain. So there are lots of opportunities in the supply chain domain. We have product design that informs supply chain design. Supply chain is often, initiated by sales and operations, and just kind of ensuring that there are some orders and there's a market, but then it breaks down across a whole bunch of different domains within an industry, within a company. So you have, sourcing, obviously procuring the materials and components, producing and production, assembling everything, then warehousing, storing everything, transporting it out to hubs, delivery hubs, all the way to the point of sale, and then the consumer interactions. That being said, there's tons of potential. A lot of these use cases are some that are being already put into action. Nevertheless, they can be enhanced and be joined by also looking at the data in a more broader perspective that can also go really deep, but not just focusing on the singular domain, but driving that capability across the domains. So some examples are, for sales and inventory around supplier risk management and forecasting, and sourcing around, obviously optimizing buying and optimizing procurement, so cost modeling, and then ensuring that you have the right balance of cost versus benefit from your suppliers. Production, especially scheduling, just in time, just in place production. And then warehousing, obviously utilization of the warehouse space, balancing of capacity for your resources to manage the warehousing. Transportation, tons of software solutions in the logistics and transportation space. Nevertheless, most companies, or a lot of companies, are interested in building their own solution that are much more tailored to their everyday needs. So real-time routing, obviously ensuring that there is, dynamic routing, that there's delivery scheduling in place. At the point of sale, ensuring that there is there's always inventory, but there's no over delivery of inventory, and there's not, it's just the right utilization of the shelf space, but also scheduling employees there and so on. And on the consumer side, to maintain long-term customer relationships and to ensure that, this is just moving really fast right now, ensuring that you can serve the customer with new services or recommendations, but also when it comes to recalls, when it comes to warranty, to be able to go all the way back to the source of the components of your products and be able to answer questions to the client to serve them in a timely manner. So that's just kind of, setting the scene. That being said, today I want to focus on kind of 3 areas. If you go to the next slide. It's jumping a little bit, and that is supply chain management, warranty and recall, and logistics. Again, we're not going to get too deep into each one, but just kind of to nudge you along the path to get you interested in the applications of graph and AI in the space. So supply chain management obviously is something that you might be here for, or something you work with every day, but traceability is a really big challenge, or is it a major part, the main component of but what makes up a supply chain. So there's many parts and many components come from different suppliers, mixed or assembled in a certain degree during many stages, and that could make it difficult to trace it back to the origin and also to its presence in the final product. And in order to overcome some of its limitations, graph technology, a supply chain graph, can really improve that, because it brings it all together and connects it. And I will show you a visual example in a moment, and how to connect everything from the manufacturer all the way to the assembled product and beyond. And that can significantly reduce response time compared to a traditional relational system. And there are some of the use cases here that are very specific, improving parts of supply management, obviously, manufacturing efficiency, mitigating risk, and managing costs, but also being able to manage and compare, as well as switch out or, tailor your supply chain closer to your supplier network. Warranty and recall, obviously, a big challenge when it comes to it often being vertically integrated, either specific to a domain, specific to a product, specific to a region, tends to still be done with lots of unstructured data, with lots of batch processing being done in individual non-standardized analytics. Some people just doing that on an Excel sheet, some very rule-based. Others like already leveraging maybe even CRM systems to manage interactions within that. But there's many players involved. There's the producer, there's the supplier, there's warehousing, there's third parties, there would be service stations and whatnot. And so warranty graph can really help prevent fraud and also do more in-depth risk and impact analysis by connecting the individual claims, matching them to other claims, and then going back down into the individual steps and systems that track claims and parts and services across the lifetime of a machine. And this will help you then also run some machine learning or even other statistical modeling to predict future claims and better manage that, but also ensure that supply issues arise and can be connected to these claims. Now, also, as you may know, often when there's warranty or recall, this is done in large swaths. So there's like entire product lines that are over the course of 6 months might be recalled. Whereas, having that transparency and tracking individual claims to individual parts and suppliers may allow it to really narrow it down to, all the parts and all the machines or other products or vehicles having been produced on a singular day or singular week, rather than, or across a certain range, rather than in an entire quarter or an entire season for new parts and products. And logistics end, again, what I mentioned before, tons of software for now, lots of telematics data coming into the space. And nevertheless, warehousing and transport being more and more fragmented in some areas and being more conjoined with various partners than others. And there's obviously this the never-ending challenge around all these different stages and different partners and scheduling them just in time, while there's tons of external influences and physical restraints, weather, road conditions, transportation networks that break down, tariffs, and so on. So this is something where, an individual graph solution tailored to your business can help you really identify in real time, challenges along that, play scenarios through, ask the graph what are better options, and then quickly come to some answers. And that can really greatly improve these transportation logistics, real-time shipping forecasting, and then also real-time reaction to changes in that system. Let's move on and talk about data a little bit. So this is just a tiny slice of what's actually happening. But on one hand, just to kind of put us in the mind frame of how data is structured, there's various systems that interplay across a whole bunch of different stacks. Some of them maybe a little older on-prem, some of them already in the cloud, some of them at various degrees of quality, structured and unstructured, that come together. So on the left side, we'll see more of the machine data. Most machines also have different operating systems and different formats that come together. Technical production data, and that broken down into individual data points. On the right side, really the organizational production data, talking about order data or personnel data. And then in the middle, at least in this representation, enterprise resource planning data, right? So, order planning, control center, tool management, maintenance, quality management, these types of data as well from various processes. Put that all together, it's not just a this is just a few. This is hundreds, if not thousands, of various data pools. It's also layered most often. You have the manufacturing layer, you have the intermediate layer of the execution systems, manufacturing execution systems, that is bringing that all in sequence. And then you have HQ, you have the company managing the business. And that is always interconnected in the more mature companies through microservices and in other places, in other handovers or FTP or whatever you have, or VPN side. And so it's not just the breadth of all these systems, but also the depth and the layering that adds complexity. And so now if you think about these type of three-dimensional almost setup, what lends itself better to that than a graph formation, in ensuring that the right data is connected through the right relationships in a semantic way that allows to kind of find new routes in that empty space between the current, structuring of the layer of the data. And if we just go one slide further, here's some examples for data pools. So on the product side, obviously you have documentation, you have various processes of assembly, for examples, you have the details to subcomponents and everything. You have a hierarchy to, obviously from the final product all the way to the individual components, configurations, which often can scale up to, 1 million plus variations on a product. I just have done many projects at Porsche, and a Porsche can be about 1.5 million variations. So that's obviously the extreme case, but nevertheless, it's just to illustrate, what happens in this area. Supply chains, I just mentioned. Customer, you have the master data. Now more and more holistic introductions of CRM systems that are much more powerful, that are not just master data, but also tracking interactions, tracking any sort of service history, even social media or offline communications. And warranty, as mentioned before, request numbers, request types, service types, work parts, lots of external parties that play within this. And put that all together, this is just something where, there's varying degrees of complexity in each one of those pools. So let's look at some graphs. We do have a first one to look at, which is a supply chain analytics example. And as you can see, This is kind of color-coded a little bit to make it as easily understandable as possible. We have supply chain data in red. We have product data in blue, some organizational data that has some impact onto the product, obviously. Then we have customer data that can help here. The product is, or part of the product is a product group is a vehicle. And then we have event data. We will go a little bit deeper into that, but it shows you how graphs can also be interconnected when we look at like a warranty claim graph. And then third-party data, social media insights, we have market data, we have, you can have data around really, geospatial data, anything that really you feel like impacts, your suppliers, your distribution of products, anything like that. And the edges themselves, if you're not familiar, do express a relationship between the various nodes, but they can also be not just relationships attached to that, but various features. And that being said, just having this type of transparency and interdependency and making that searchable and queryable through various through GSQL and various approaches in that really allows you to have a logical model and a semantic relationship that goes way beyond having to join a whole bunch of different tables and then not be able to see these types of connections only based on certain key elements, but not overall, especially when there's multiple layers and depths. So this can really help you improve ordering and procurement processes, especially manual processes can take a very long time through the systems. Graph can be instant. Saving money on ordering, making smart decisions, for example, to see where there's patterns where that allow you opportunities to buy in bulk or to save money in other ways. Organizing inventory, seeing in the webinar last week, there was a great example from JLR, Jaguar Land Rover, where you can track, for having an overstock on seats or some issues where parts are missing to install certain seats in a certain type of vehicle, but then realizing that they can be used someplace else, even in a different region or a different plant. Those kind of instant tracking mechanisms that you can build in or ask the system are something very unique that's only possible in a graph database. Now, it's not to say that it should replace any sort of relational database or any other existing systems, but can really bulk it up and enhance it. And then, doing comparative analysis, comparing suppliers based on warranty claims, seeing faulty parts, comparing logistics, regulatory compliance, if there's something that you continuously want to track from the outside, and so on. Speaking of claims, let's go one further into a warranty claim. So here we have the a warranty analytics graph. So this is we have a bunch of claims in gold, at least event data, or in ochre color here, which are related to triggers for certain events around a claim or a recall. And this allows you to connect that to individual products, individual customers, but then also to through the supply chain to then deep dive into the previous graph to then locate, quick mitigation of the situation. Leveraging a graph and running some machine learning on this graph allows you then to also predict future claims, like especially looking at certain patterns, looking at, is there expensive issues that I need to be warned about early? Is there easier ways to resolving based on past history, resolving certain issues? Are there pools for suspicious cases, inflated cases, looking at outliers, and then thus predicting also future impact of claims or types of future claims that could be coming in. If you leverage, certain signals out of product data, telematics or sensor data, this could also allow you to then quickly find triggers across the system and continue to scan for those by just simply querying your graph, exactly. And a last example is a logistics analytics graph. So this is a very simplified version of it, but I think it's, I mean, there's nothing more natural, or there's no more natural graph, similarity to a graph than looking at a map, right? You have various hubs, various cities, various stations, and then you have connectors, which are mainly roads, but it could also be shipping routes, or it could be flight routes. Nevertheless, there are intersections that could be anything from a road junction to some sort of, transfer hub or whatever, but also focusing on the individual main hubs between the factory and the recipient, and then associating various, features to each edge, to each and then to each node, in order to then computing something like shortest path, but shortest path for the day. The shortest path is not always by distance. It could be something that you that it could also cover coverability of terrain. It could be something like, current outages along the road, all that being put into perspective, and having then other ways to shift inventory and shift transportation for the day or the hour. And when you need to scale, especially standard software, that's when you run into issues often, where a graph database allows you to scale at a really strongly or really high level. Other more proprietary software might be limited within that. So having an additional custom solution, or something that works in conjunction with your current one through this property graph, could be very useful and helpful. And that's, having queries even for mitigation purposes go down from, at one client, we did that from 20 minutes down to less than a second, which really helped then set and accelerate these processes as, minutes count, especially during the transportation logistics process. That being said, that was just a really quick introduction. How do we approach these type of projects? Well, being a consulting company, we attempt to really focus on the value and build POCs and do projects initially as a POC, a prototype, in an agile manner. But that being said, it's really important to kind of follow a few steps. So one is that number one is implementing it, obviously, and leveraging the technology, but having a simple use case in mind. I just mentioned a whole bunch of examples, but picking one that really is focused on a process where you are losing significant cost or time, where you feel like there is the most, it's a big pain point. There's lots of, there's a high lack of transparency and so on. So the way we start is PartnerGraph is a great example of a really powerful technology that can work seamlessly along your existing infrastructure. So that's something where we install it. We then load data into it in parallel. So since PartnerGraph sits along other storage, we can do that in parallel by just transferring parts of it. There's a native loader, for example, for CSV files, or really any type, with an ever-growing library of loaders and connectors. And the schema is then designed to almost exactly reflect the data loaded. And there's some data quality checks that can be happening as well there. What we call the PS Analytics Engine, this is really where we build a workbench, often in Azure or AWS, sometimes in GCP, that allows us to do some BI work, but also run machine learning on top of these various data storage components, ideally, or in this scenario, on the PartnerGraph database, and then report it up to then also not just have numbers to come out of that, but also be able to visualize and then quickly deep dive and use self-service BI tools of various ones to then showcase. Xperia is one of them that they actually showed last week, but to then showcase what is actually happening in that data and what these results look like, to then quickly put that into action. Building a graph is something that I just showcased on the next slide. So this would be a first prototypical basically showing that it's doable, proof of value, and showcasing that we are able to provide a queryable and understandable view of highly complex data. Within that, that is something I just showcased in a few graphs. But the key is then in the next step to build user-centric dashboards in order to make that consumable. So that's the next slide. So leveraging something like Graph Studio or even other tools that you may already use in Power BI or Tableau to then have the view across the graph, but also feed the information into your existing BI and reporting, so that in that combination, you can on one hand see changes or see red flags or see and track your KPIs. On the other hand, have a method for doing a deep dive and really looking at relationships between these events. And then in the last step, this is something where we can also leverage more advanced methods, to do more in-depth sales planning. For example, using scenario modeling. So in this scenario, this is something where production lines, processes aim to balance, obviously, the rate of production, and so that of any particular model, so that the order slots are usually planned about 2 weeks ahead, and then the sequencing is matching up the parts and ensuring that there's a high utilization while reducing the cost per unit. So, as an example, in automotive construction, that, the doors are already aligned by color in the sequence of the cars that are being built. So, red, white, blue, whatever. And then if that doesn't happen, then there's line stops, which is the worst type of, scenario that could actually arrive. So there's some production constraints there. But also there could be, machine failures, like a robot breaks, the paint shop has a problem, there's some chemical issue, all these kind of things. So having this end-to-end model of the entire process, like orders, units, parts, sales order book, then helps you build better forecasts for the week. And then you can leverage optimization algorithms to directly model the ideal flow of parts from supply through the manufacturer, and then greatly improve planning and sequencing, as this is not just happening at the production stage, but way earlier, directly from sales planning, to really arrive at that golden zone where this is all in sync. And the underlying GraphDB technology allows you to really build these scenarios in real time. Yeah, so much for that. And here's just something that we've built for our clients as a product, which is something that we leverage in lots of projects. So we've built a solution that we call Knowledge as a Service. And what it does is it has a whole bunch of services that allows to do NLP, natural language processing, and extract information and create a logical model around do entity detection on all types of different internal documents, and then allow you to do a lot of real world applications in the next step, in the next slide, such as cognitive search. We have a knowledge graph that we can use for, disambiguating text and entities, and quickly doing searches. This is something, I mentioned earlier, we can really do powerful queries. Semantic ranking, so that is ranking suppliers or ranking certain policies, or highlighting specifics that need to be ranked versus other content. And then chatbots that can draw from this and be trained and then apply, semantic search directly to questions that are being asked, and then, have something that's really specific to, certain parts, or, get really domain specific information. This is something that we've put together for an energy client. And the next slide is just a quick case study of that. It's basically a digital research assistant for an energy client, and for the strategy department, a strategic planning group, found it difficult to analyze, extract, and aggregate tons of market intelligence and align it with their internal intelligence. So this platform is kind of the missing link between those. So it's a knowledge discovery application, allowing or being an expert assistant, leveraging graph technology for advanced search and question answering. And it had a significant uplift in the productivity of this department, which allowed them not to then reduce staff, but really focus on more efficient work and more quality output. Yeah, and so just to summarize as a wrap up, graphs are particularly useful in manufacturing, just because the systems that are in place, especially in supply chain and in a structured environment, lend themselves very well to graph technology and the representation in a graph. It helps you to really quickly unlock exponential value pools, being that the fact is that putting this data together in such a way and making it queryable is something that can feed a ton of use cases, and it can support and even accelerate your AI efforts, such as, just like the space shuttle is using the gravity of planets, you can really slingshot some of these efforts into the next level, and using more of these advanced modeling approaches, as well as improve your forecasting as you might already be doing it today, and then really enhance your application of AI across the enterprise. I hope this was helpful. As a quick introduction, again, I would recommend the webinar from last month, which I really enjoyed as well, which goes a little bit more technical and shows a demo of another software provider. And I think it really aligns also with this story. So hopefully you are convinced to now apply this technology in your domain. Thank you.
That was terrific. Thank you, Amadeus. I can see that you put a lot of thought into your presentation. I especially like the narrative that you constructed across the 3 graph types: the supply chain graph, the warranty graph, and then the logistics graph. That was very powerful, very interesting, very informative, and I'm sure our audience will agree with me that this has been very insightful. So now it's time for questions and answers. If you haven't already submitted a question, please do so through the Q&A button. Some of the questions we've got are, first one is, what are some of the challenges you encounter getting started?
Yeah, as it is so often, it's not necessarily the technology, but it's the organization. And so being in consulting, I kind of want to focus on that a little bit. So getting the buy-in and finding the right stakeholders is obviously something that should carefully be thought about, and getting more than one person or one department on board. So because when you build this, you're extracting data and you're linking data that can have exponential value by this connection, by this new way of joining this intelligence, and then having more than one stakeholder on board and that can benefit from this will greatly get you the support, greatly support this initiative. And so slicing it down in manageable steps is something that's also helpful, which then can be, you continuously share more insights and more impact. The access to data obviously is something that it always comes up, so it's always important to leverage as much real data extracts as possible. But what we often encounter is also that it's helpful to synthesize some data that you might not have access to at the moment, or just kind of you only have a small pool of, so create an additional data replicating existing data in order to, or leveraging expert knowledge and creating some data so that you can at least get a sense of how the graph interconnects, and you might want to select future data pools and connect them. And then not necessarily, and then also something, another mistake that I often encounter is when there is no clear focus on a well-defined pain point. It's just kind of done as an exercise to check out technology, which there's nothing wrong with it. But in order to gain traction, it needs to you need to select a use case where you're actually really extracting value, and you having that aha moment that there's something that you couldn't do without this type of access to information. So looking for a challenging area, ideally where money is lost, or especially that manual effort is high, where maybe motivation of colleagues is low to continuously do these tasks, and then just having that ROI, that's something that, making an impact versus feasibility assessment, a quick one, even just in a workshop, maybe seeing like, is this difficult as a manual task? Is the impact then great? Is it easy? Is it feasible to get some of that data and then get started?
Very interesting. Good answer. Very thorough. Another question is, what are additional features one can expect to help forecast accuracy using graphs?
That's a good one. Well, that's really depending on, the question of what you're trying to forecast. What I do see, though, is that there is a strong trend towards leveraging external data, third-party data, or even looking for strong partners and second-party data, where you are able to then get a new perspective on this. As I try to convey through, supply chain graphs, they really live and breathe by, or they really give you that extra insight by using data outside of your domain, and just having then, additional types of inputs, or even enhancing some of these features that you have in your model can then enhance predictions. Plus, it allows you then also to kind of check it against, other types of data and other scenarios, and also do more of a correlation analysis, why certain predictions are in a certain way or not.
Okay, great. Another question is, you mentioned a customer reduced planning time from 20 minutes to a few seconds. I think this is when you were showing the logistics graph. Can you share more?
Yeah, I can share a little bit of that. That's something, especially when there was, so this was basically about a manual handover between two business departments, which there was a very complicated way of having, data being transferred through various platforms in order to ensure, and there was a big disparity between real-time data and some of the batch data. That being said, though, since data on certain areas didn't change that much, and being able to connect it to other cases that were very similar to in the past, especially along the logistics handling, we're able to then really cut out these manual processes. And a graph was something that leveraged. So this was basically a very complex join of many tables, which was eliminated by one single graph. And that alone allowed then to do queries for specific questions around, what is a better route? What is a better, should I switch warehouses today, and so on, and reduce that to just an immediate answer. So that's really something that was before just done in a very complicated way. So it's that's what I encountered.
Mm-hmm. Mm-hmm. Yeah, another question, I think you touched on this already, is how do you initiate change in an organization to move to this new approach? I think you touched on it.
Yeah, it's really about communication. Ideally, you capture the interest of early adopters and people who are looking to find new ways to address old problems. And so once you have built a POC or had a chance to find somebody to be a driver of an initiative, what really helps is to then work on a communication plan together, do some brown bags, maybe a roadshow, internal tech talks or similar, and then or get some space in a company blog or website and just make it internally available for people to try out for themselves. Really also look for opportunities to spread this impact far and wide, just get people excited about the possibility of finding a new way to look at existing data, or to minimize meetings, reduce on-screen time in Zoom meetings, but also then not to think about replacing a process directly saying this is the before and now we're only going to do this, but ensuring that, especially when you use graph technology, it's still kind of a big change often, but use the tool as a complementary accessory. Ideally, if it's focused on value, then people will organically switch. And then last but not least is to have a cycle of improvement. So be open to critique, ensuring that you can do quick optimization, improvement cycles, and ensuring that you can extend or reduce areas of your graph, and then continuously work on updates and upgrades based on that user feedback. So people also see that when they are using it in your company, that their wishes or their suggestions are being then, integrated.
All right, cool. Yeah, so we've had a follow-up question to the original one from Mahesh. The original question was asking about what additional features do graphs enable to help with forecast accuracy. Then the follow-up was, thank you, just to reconfirm, we are using external data to improve forecast accuracy that's independent of graph specifics. And then the third part of this question, or is it that we store external data as well into graph and gain additional / richer feature sets to influence the accuracy of forecasts?
It's the last one. Also, it helps you with, thinking about, kind of pulling apart correlation and causation a little bit, and also validating your models. I'm not a data scientist, so that's as far as I can go on this.
Awesome, that's great. Thanks. Okay, I think we've grilled you enough with questions. You've been talking for the best part of an hour, Amadeus. So I think that's all the questions. So what we'll do is we'll move. Well, there's one question in chat. Thank you, from Mahesh. Thank you, Mahesh, for your questions. And we'll just move forward and finish up. So this was, I'm sure you'll agree, this was a very informative webinar. And again, thank you, Amadeus, for sharing your thoughts and also putting as much being as mindful as you have been in terms of creating an interesting narrative. Upcoming webinars, we have 2 more scheduled. This schedule, our webinar plan does change quite frequently, but currently we have a webinar scheduled for August 11th, and this is with Xilinx and a colleague of mine here at TigerGraph, and the topic is powering the next generation machine learning solution with graph analytics on connected data with Xilinx and TigerGraph. There's a typo in TigerGraph there. And then at the end of August, another webinar with another partner webinar, accelerating graph analytics to answer complex business questions. That sounds very intriguing. Those questions could be quite broad. So that's one to look forward to as well. And that's with Hewlett Packard Enterprise. And we have a speaker from HPE and also Dan Eaton, my colleague from TigerGraph. And if you'd like to know more about our webinars, please check out that webpage, tigergraph.com/webinar. Like I say, I'm sure we'll be adding more webinars. Perhaps we'll be even doing some later on this month. But that's the schedule as at the moment. And then just to wrap up, please feel free to contact either of us. I think Amadeus would be especially interested in hearing from you and getting feedback and your thoughts on how graph can be applied in these areas that he articulated. His email address is shown there. If you want to learn more about Publicis Sapient and their consulting expertise, please do so at the URL. Or if you're interested in joining our partner program, becoming a partner of TigerGraph, please go to that URL, tigergraph.com/partnergraph, and sign up, and somebody will contact you. And I think that is it. How are we doing on time? 50 minutes. I hope the audience finds this to have been a productive use of time. Again, we know everyone's very busy. I think we're all busier than ever these days. And Amadeus and I very much appreciate you taking the time out of your day to spend time with us. We hope you found this to be informative and interesting, and we look forward to seeing you again in the near future. Thanks, everyone.
Thank you very
Bye.
much.